All right, ladies and gentlemen, yesterday we talked about two theorems. We talked about congruent complements theorem and congruent supplements theorem. What I'd like you to do right now is here is a proof that I want you to do with your partners. You're given that angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 3 as well. I want you to prove that angle 1 is congruent to angle 2. You don't need a diagram for this. But what you should do is copy down the given on your own paper, copy down the proof, and then what you do underneath that is write the word statements and reasons and draw those bars. With your partner, I want you to prove this in as many or as little steps as you can. You can't use the theorem that we're talking about to prove this. So you're going to have to use arithmetic or algebra to make that happen. Take about 5 minutes. Okay, so you've finished your proof now as much as you can. Let me show you what mine looks like, and I'll explain it as I go. So number 1, you have to have your given statement. Now, because I told you that you have supplementary, you have to use definition of supplementary to create your relations. You should have that the measure of angle 1 plus the measure of angle 3 is 180, and the measure of angle 2 plus the measure of angle 3 is 180. From that, I can see that since both left sides are equal to 180, I can cut out the middleman, so to speak, and just make the 1 plus the 3 equal to the 2 plus the 3 by transitive property. You could also say substitution, but this one's a pretty clear transitive property situation. From here, I notice that I have measure of angle 3 on both sides, so I can subtract it from both sides and have the measure of angle 1 equaling the measure of angle 2 by subtraction property of equality. Some of you may have put in a step that says the measure of angle 3 equals the measure of angle 3 by reflexive property, and you can have that. Now, number 4 and number 5, I've written as 2 separate steps. You can write them as one step as well. Because we've worked with algebra, I need to convert it over to what they're trying to prove, which is a congruency statement. So what I've done here is I've said that angle 1 is congruent to angle 2 by definition of congruence. But if you just want to write step 5 next to step 4, I would accept that. So what did we actually prove with this proof? What theorem did you just prove? You just proved the congruent supplements theorem. And this is what we talked about yesterday. If two angles are supplementary to the same angle, then they're congruent. In this scenario, this is what we talked about yesterday. 1 and 2 were supplementary. 2 and 3 were supplementary. So by the theorem, angle 1 and angle 3 are congruent. And we just proved that in the above proof. So now you can use the theorem in other proofs. So now I've given you a handout with 3 proofs on it. Portions of them are filled in. You can use any theorems that we've proved in class so far. So you're not proving any theorems here per se. You're going to use those theorems. So take probably 5 to 7 minutes. There's 2 proofs on the front of the sheet, 1 proof on the back. Work with your partner, and then I'll show you the answers. All right, go ahead and check your work. So we have given. The one that's supplementary means that you're showing the mathematics in algebra. 1 plus 3 is 180, angle 2 plus angle 4 is 180. From there, I can make a statement that I'm cutting out the 180 and setting the left and right side equal to each other. You can say transitive property, you could also say substitution. All the substitution would occur in step 2 though. From here, you can say vertical angles are equal only in the case of angle 1 and angle 2. So the measure of angle 1 is equal to the measure of angle 2. So number 5, they're showing you that you're using substitution here and replacing angle 2 with angle 1 from this step 4. You don't necessarily have to show that step, but it makes your proof stronger. From here, I can subtract the measure of angle 1 from both sides. So you have the measure of angle 3 is equal to the measure of angle 4. Notice we're trying to prove something that is a geometric relation, so we do have to change it back over to geometry. You can do it on the same step, or you can add the separate step in that angle 3 is congruent to angle 4. Let's go ahead and look at number 2. So we say that angle 1 complements angle 2, that's your given. And by definition of complementary angles, the sum of the two angles is 90. And I should have a measure, the letter M's there. The measure of angle 1 plus the measure of angle 2 equals 90. Then I can put in the measure of angle 1 equals the measure of angle 2, or sorry, measure of angle 1 plus measure of angle 2 equals angle AOC, which is by angle addition postulate. And I should also put an M in here for measure of angle AOC. From here I'm going to use substitution and write that AOC is 90. You could get away with using transitive property here because the measure of angle 1 and angle 2 are in both of those equations. And from here, you can say that if you have a 90-degree angle, you have perpendiculars because definition of perpendicular lines. Let's go ahead and take a look at number 3. Number 3, you're allowed to use the theorems that we've proven. Now, we've proved the congruent supplements theorem. The proof for the congruent complements theorem is the same proof, just with a 90 rather than 180, so you're allowed to use it. So your given is that 1 complements 2 and 1 complements 3. So right away, I can say that 2 and 3 are congruent by the congruent complements theorem. Now, if you can't remember that, you can write it out. If two angles are complements of the same angle, they are congruent. Now, since angle 2 and angle 3 are congruent, that means that ray PS is bisecting the angle. If your angles are congruent, then you've got a bisector. And that's by definition of an angle bisector. Because the definition says that if you have the angle bisector, it's the two angles are congruent.